Definitely be sure to follow those instructions on the handouts for all the assignments for teaming up, that is. Because if you are going to team up for assignments, you need to make sure that you are teaming up in Canvas and forming an assignment pair so that all of our scripts work. Otherwise, whoever that second person is, they're not getting credit, at least initially. Of course, we'll reasonably make accommodations and fix it later on, but at the same time, you should be following those instructions. All right? So we are now live, and we're on, just let me make sure, yep, our audio is working fine here. Remember that we do have online on of course, YouTube, but especially the Q&A on Piazza. If you have questions mid-lecture, please go ahead and post it there. We've got 11 following online, 4 in class. That's just for my own information here. Last week, we covered everything with respect to loops. And so what I was going to do is I was just going to use today as a session where we can get more practice. So these are all exercises that I've assigned in the past, either as a homework or on a midterm or a final or something like that. And so we're going to do as many as we can. Some of these I did yesterday, but for variety, what I added, I took some away, I added some in here. But for variety, what we're going to do is we're going to do them in Java instead. So if you want to see how that, like this first one is done in C, go ahead and watch the video from yesterday in the main section. Let's go ahead and do this one in Java instead. Write a program that constructs a multiplication table for values 1 up to n, where n is read as a command line argument. So for that, I'm going to go ahead and go over here to my Eclipse. And we'll go ahead and put this into the default package. Right? Unless it's specified that you put it in a different package, you should always just put it in the default package, or something that makes sense for you. The grader, of course, is going to expect it to be in a particular package. So we'll just call this a mult table. Right? Yeah, default package is discouraged in general, but for your assignments, it's okay. Right? Now, what's the first thing I should do? I should include anything that I'm going to eventually import, but I should also make sure that I document everything. One of the common errors that we saw was missing documentation. Most everybody had documentation. Author, me, date is 9/08, and the purpose of the program. This program generates a multiplication table based on the user's provided input read as command line arguments, right? As CLAs. Right, there we go. So that's pretty good. Remember also that documentation, at least in Java, is attached to the class. If you have a package declaration, that goes up at the top. If you have imports, that goes before the documentation as well. So if you've got an import, then I don't know what we're going to import here. Eventually, we're probably going to import something, maybe, I don't know. But we'll go ahead and leave it blank there until it's time to do so. In fact, we're going to let the IDE do it for us. So next we need a main, public static void main string args. We saw one submission that did this wrong and did this as doubles, or maybe that was in a lab or something like that. That is not a main. That is not a proper main. The only proper main, that is a different function, and you can define that function, but the only proper main executable that makes this executable and that I can hit the play button up here is a function with this signature here, this public static void main string args. Yeah?
So if you did it like double, it wouldn't even run?
If I try to run this, it's going to say that there is no main. Right? In fact, it ran something else entirely, I think. Right? But yeah, you're going to get an error that says that this is not runnable. Okay? Or something similar. Right? Let me give some nice, let me free up some real estate here. Right? There we go, and go down here. There. All right, so we're going to have to read that in from the user. So how do I read command line arguments from the user? I just take args, and I'm going to read in an n, right? So an int n equals integer.parseInt of the first argument, args of. Now in Java, what's the first argument? What index is it at? Is it at 0 or is it at 1? 0. The first one in C is going to be the 1 because the argv of 0 in C, that's the executable file name. So remember that. I chose to make this an integer because I'm writing a multiplication table. It would probably be inappropriate to have a double because you don't have a table where you've got 1 and 1.5 and 1.6, or right? How far do you go? There's an infinite number of things in between your table. Right? There we go. All right, so the idea here is that I want a multiplication table. So I want a header where it's 1, 2, 3, 4, 5, all the way to n. And over here, I want a column of 1, 2, 3, 4, 5, all the way to n. And for each I and for each j, I want the multiplication of I and j. So at row 2 and column 3, I want 2 times 3, so 6. Right? What kind of what loops should we what kind of a loop should we do here? A while loop or a for loop? What's more natural? For loop, because we know exactly up front how many iterations we're going to go here, n. Right? So let's go. What I want. Let's take care of that first row though first. All right. So what I want to do is I want to not out.println something like this, right? Nothing, and then 1, and then 2, and then 3, and then 4. Should I hard code it like this though? If I want to read in n and go up to n, so sometimes I want to just do 4, sometimes I want to do 10, sometimes I'll do 10,000 or something like that, right? No, let's go ahead and write a loop to do this for us. So for int I, starting where? Do multiplication tables usually have 0? 0 times 0, it's just going to be a bunch of zeros. So we'll start it at 1. I is less than n, I plus plus. Does that sound right too? What will this go up to? If n is 5, it'll go up to 1 less than that, 4. And so I want to go up to n including n here. Right? And I'll go with system.out.println, or not ln, but printf, right? %d and I. Right? Let's run this. Remember, if I run this, then I get an exception. Why? Because array index out of bounds here on this line. You can click this stuff, that's why it's highlighted in blue. It happened on that line. Right? Why? Well, because I didn't provide a command line argument. So let's add some defensive, let's make sure our program is well designed, and we add some defensive programming here. If the number of arguments is not what we expect, oops, not 10, but 1, then we will issue an error message, system dot. Now we could do it like this, printf error, provide an integer n, right? There's another way that we could do it though. Instead of out, we could go with error. Right? And the only difference here is that, at least in this IDE, is that it'll highlight it in red. This is a different output file stream. There's the standard input, which is mashing your keyboard. There's the standard output, and then there's the standard error, which standard error and standard output basically go to the screen, but they are 2 different streams. Okay, there is a difference between the 2, and then we'll go ahead and quit on them very rudely. Right? Exit with an error code of 1. 1, something happened. Right? True, something happened. Okay. Now let's go ahead and try that again. If I provide no command line arguments, then I get that error here. And you see that it's highlighted in red in my IDE. It's red flashing means something's wrong, right? Okay, so how do I provide command line arguments in my IDE? I go to Run Configurations, Arguments, and we'll go ahead and keep it small initially, 4 here. Apply and run. There. And now it actually executed down here, but it doesn't look nice at all, does it? Right? So let's add some spaces here. Run that again, and now they're at least spaced out. Still doesn't look nice because I don't have that initial column there. So system.out.println, I'll go ahead and have nothing, right, and then a space. And now I'm set up for everything afterwards. Oops, not println, but just print. There, now it's all in the same line. Okay. Now I need to take, for each row, I need to go through for each column. So, how many loops does that suggest to you? For each row, you can write it out like this. For each column, and then start giving them names, like for each row I, for each column J, right? I'm doing this basically kind of like pseudocode, an outline of what I want to do. For each row, for each column J, output the I times J, right? That's just my general outline here. So, probably going to want 2 for loops here, and they're nested. For int I equals 0. Oops, so I started at 0? I don't know. I is less than or equal to n I plus plus, 4 int j equals 1. J is less than or equal to n j plus plus. And then transcribing this, output I plus j, I'll go ahead and steal this up here. I, not I plus j, but I times j. Okay? All right, let's see what this looks like. Terrible. That's not a table, that's a row. I need to line break after this, right? This should be 1, 2, 3, 4, the next one, then times 2, then times 3, then times 4. Where do I put the line break here? Should I put it here? Yeah, go ahead.
After each n.
This was for each column, right? So when I'm done with all the columns, I'm done with that row. So system.out.println, or just print the end line. Right? Likewise, I'll want to do that up here to break on that first line right here. Okay? And when I do that, it looks a little bit better. Right? But what am I not doing over here in this column? Right? This column should be shifted over, and I should be printing out the I that I'm multiplying by. So one way that I could do that is I could start this at 0, and then if I is 0, then print out I, printf, else do this stuff, sorry, this actually should belong in here, right? And then I'll just start j at 0, and if j is 0, then I'll print j in the column here. That's way too complicated, right? Just take care of it simply. KISS, right? Keep it simple. System.out.println, or printf, let's say, %d, space, and then I. And when I do that, it looks much better now, because now I've got, there's my row, here's my column, and of course I've got a repeated column over here because I start at 1. Right? 4 times 4 is 16. Still not all that satisfying. Why? Does that look like a nice, well-organized table? No. So how can I make sure that everything is lined up? By putting in those modifiers, remember? 3, 3, 3. I'm going to print at least 3 columns every time I print a number. And when I do that, I get this nice, I have to do it on the first one too, sorry. Oops. Actually, no, I did it on the first one. I didn't do it on this one. So 1, 2, 3, there we go. And now everything will be shifted over properly, I think. Yep, there we go. Or I could have done space, space, and then nothing, or just 3 spaces or something, right? And now everything is nicely aligned. Let's make sure that it actually works if we have different configurations. We'll go up to 10 by 10 multiplication table. That looks nice. Right? What if we went up to 100 by 100? Now our alignment no longer looks all that great because now we have numbers that are 4 digits. And in fact, over here we have numbers that are 5 digits. So back to the drawing board and increase the white space alignment if you really want to 5. But has anybody ever seen a 1,000 by 1,000 multiplication table? No, not reasonable. Okay. All right, I'm satisfied with that. Let's do some math. Write a program to compute the arithmetic geometric mean of 2 numbers. So hopefully everybody knows what the arithmetic mean of 2 numbers is. A and B, you add them together and divide by 2. What's the geometric mean of 2 numbers A and B? Yeah.
Is it like squaring?
You don't square the numbers, you multiply them together. A times B, and then what do? Square root of it, right? The arithmetic geometric mean is basically where those 2 values start to converge. Right? Now there are various ways of interpreting this, but basically you're converging onto 2, that you repeatedly take the two numbers and you take their arithmetic mean and their geometric mean, and you keep doing that over and over and over again until they're equal to each other, or as far as coding is concerned, they're close enough. All right? So let's go ahead. Do we want? Let's do this one and see. Sure. Let's see. We can whiteboard an example here. Yeah, let's do it over here. Right? So down here. Oops. Example. In fact, this is a good exercise. To understand a problem, you whiteboard an example. Now, I could go up to the whiteboard here, but the audience at home would not be able to see it. So what is the arithmetic geometric mean, AGM, of 1 and, say, 4? Right. Well, first of all, we take the arithmetic mean, which is going to be 1 plus 4 divided by 2, which is equal to what? Oh, come on, why aren't you not? 5 divided by 2 is going to be 2.5. Why are you not? Come on. Why are you having so much trouble with this? There we go. And what's the geometric mean? We take square root of 1 c dot 4. Sorry. LaTeX skills. There we go. Which is going to be 2. There we go. 1 times 4 equals 2. Now those are already very, very close, but they're not exact. In fact, I mean, they're off by an order of half, right, which is still an order of magnitude. So we repeat. Now our two numbers are 2 and 2.5. What's their arithmetic mean? Well, I just put what I did up above top. Instead of 1 and 2, or 1 and 4, it's going to be 2 and 2.5. And what is the answer there? 4.5 divided by 2 is going to be 2.25. Is that right? All right. Help me out with my math. Geometric mean is going to be, I'll copy paste up above, and instead of 1 times 4, it's going to be 2 times 2.5. And what value is that? 5, what's the square root of 5? 2.236, right? 2.236. 2.236. There we go. You see that they're even closer now? Right? Always getting closer, always getting closer. They're always going to converge on each other, right? So it's basically the arithmetic geometric mean is as long as they get close enough, right? Now, in the infinite, if you take this infinite series, then eventually, then they're never going to actually, be equal to each other except for some special cases. But they are going to converge to each other until they're very, very close. So we can't have an infinite program that computes it forever. Instead, we have to build in a tolerance. If they're to within 0.00001 of each other, that's when we'll stop. Right? And then we can parameterize that and call that epsilon. If they're within epsilon of each other, then we'll stop and say, okay, well, that answer is good enough. Right? This is kind of what you're going to do tomorrow in your lab, where you use a Taylor series to compute pi. Taylor series are going to go out infinitely. Right? But you can't do that with a computer. Instead, you have to say, okay, well, I'll compute the first 10 terms in the Taylor series, and that's good enough. That's a good enough approximation of sine. Right? So let's go ahead and do the C version of this. Right? And I'm going to parameterize absolutely everything here. So let's go ahead and go with a new file, agm.c. Right? What's the first thing I do? Documentation. Right? Author, me, date, 0908. Oops. And purpose, right? This program computes the arithmetic geometric mean of the two input values given as command line arguments, right? And we'll go ahead and also maybe eventually parameterize epsilon here, okay? We'll include the standard library, as is best practice. We'll include the standard input-output library. And if we're going to be doing square roots all over the place, what else do we need to include? The math library. So your standard main will accept two values from the command line arguments, A and B. If argc is not equal to something, then we'll go ahead and issue an error message here. Printf error provide two numbers, A, B. And then we'll quit on them with an error message. Now, if I'm expecting two numbers, and this is C, how many command line arguments should I be expecting? 3, right? I have trouble holding up 3 there, right? 3, there we go, right? So, why? Because that first one is the executable file name, a.out, or myawesomeprogram.exe. Question online here is, how do you know when to do author name into your intro or the annotation? So that's a good question. Over here, this was auto-generated by my IDE. There are a bunch of annotations that you can use in doc-style comments. For example, you can link to other things. You can say at link, or no, at. You can put in, you can embed HTML if you want. href equals wikipedia.com, right? C. You can go do something like C Wikipedia for more information. Right? In fact, I'm sure that there's a Wikipedia article on multiplication table. Yeah, wow, okay. So I'll go ahead and link this. And when you generate documentation like this, let me go ahead and hover over this. You see that this is turned into a link. And if I click that, it'll of course take me to, well, eventually once it launches, right, there we go. It'll take me to that link right there, right? And that's a nice way that you can annotate your documentation using doc-style comments. It's not going to be supported in the CS50 IDE, so it's not all that important. But if you are using a doc-style comment generator and it generates your documentation, then you can link in, throughout your documentation. So for example, you can also do something like at link, what is it? I forget how to do it. Main, is that right? Yeah, I can go ahead and click on the main and that will take me over here, but there's no documentation here, so you can put document, this is the main, right? There, now when I hover over this, and I want to know more about the main method, okay, that's not how you do it. Oh, there we go. This is the main, right? I just clicked on it and it takes me to another piece of documentation. So that's why you would want to use these kind of annotations here, right? Yeah. That's generated by however you set up your Eclipse. This is probably just pulling off of my Mac here, that's my username. You can go ahead and change that, Chris, or if you want, it doesn't really matter. Now it's my full name. These annotations are used all over the place. Links, external links, references. Looks like only author is supported here, right? Or it will come up automatically, okay? All right. You can do the same thing over here if you really want to, but unless you're going to be using an external tool to generate a bunch of documentation, it's not that important. Right? But it's important to get into the habit of writing good documentation. Make sure my indentation here is consistent, right? If I only indent 2 spaces here at one level, I only indent 2 spaces here at the second level. Right? Now let's go ahead and read those in. Int a is equal to a to I of arg v sub 1, and int b is equal to a to I of arg v sub 2. Should those only be integers? you can take the arithmetic geometric mean of 3 and 3.5. So why should we restrict ourselves? Let's make them doubles. If I make them doubles, should I have a to I anymore? A to f, okay? Let's go ahead and define an epsilon for now. Epsilon. We'll go ahead and hard code it to be 0.001. In other words, when they converge so that they're within 1/100th of each other, then we'll stop. That's close enough, right? Over here in this example that we did, they're not within 1/100th, so we would go another iteration here and get it even closer. Right? Of course, you could go 1,000th, 1/10,000th, right? Of course, you can go overboard here, and that's going to require a lot of iterations, right? But we'll go ahead and keep it simple for now and keep it like this, okay? So let's go ahead and start computing those values, right? We can go ahead and try to do what I did over here and try to, well, what's the first iteration look like? The first iteration would look like double A next, say, is equal to A plus B divided by 2. Right. That's the arithmetic mean. And then I could do double B next is equal to square root of A times B. Right? And so I've got those next values. Over here in this example, that would be 2.5 and 2. Then I would have to compute those again using the previous values. A next is equal to the previous value, A next plus B next divided by 2. B next is equal to square root of A next and B next. You had a question? Go ahead.
No, I think you answered the right question.
Okay. Then we keep going, right? There's the next one, there's the next one, there's the next one. Let's just make sure that our answer so far was correct. Printf of AGM of percent F, percent F. These are the two input numbers is equal to percent F. And the line A, B, and then if A next and B next are close enough, then you can print either one, right? Because they're within epsilon of each other. I don't have any loops here at all yet, right? We're not done yet. GCC, AGM. Oops. What do I need to do if I'm using math? There we go. Provide two numbers, please. 2 and what did I have before? No, 1 and 4, sorry, right? All right, 2.25. That jives here with the first iteration right here, right? And so we're on the right track here. Get rid of this, more real estate. There we go. So how do I codify? This is just 2 iterations here. Well, I could go ahead and go with 3 iterations, 4 iterations, right? But I'm just doing the same thing over and over again, right? 2.16, right? In fact, we can make sure what is the arithmetic geometric mean of one AGM of 1 and 4. Hopefully it supports it over here. 2.24, right? So we're that's the decimal approximation of the AGM of those. So we're getting there. Oh, sorry, we're getting there. Right? And I do think that it's going to be oscillating. It'll be an overestimate, underestimate, overestimate, and then until it gets down to where it needs to be. So if I went one more iteration, I'm sure that I would overshoot it. What was it before? 2.16? Oh, nope, it looks like we're getting close. I started with 1 and 4, right? Oh, you know what? I screwed up already. I've changed my AGM before I've used it. Okay. I'm glad I did this exercise. So let's rethink this. I've got an A. I want to definitely keep track of the current A and B, but I also want to keep track of the previous A and B. Right? So let's actually go ahead and set up those variables. Instead of thinking about next, let's think about current and previous. So A, previous, I'll initialize that to something. B, previous, I'll initialize that to something. Where should I start these? I could start them at A and B, right? And now, if I'm going to do this over and over again until it's going to be overestimate, underestimate until I get to what I want, then what kind of a loop do you think is most natural here? A for loop where I know up front how many iterations I'm going to go, or a while loop where I don't know how many iterations I'm going to go, so I just keep going until it's close enough. Okay, while loop. And we'll come back and fill that in later. Actually, let's do it now. While A and B are not close enough, right? While the difference between them is larger than epsilon, while A minus B is greater than epsilon, right? Except that I already said that it oscillates, right? It goes up and down, up and down. So the difference between A and B, is that always going to be positive? No, it could be negative, in which case we stop, right? Immediately. So what do I really want here? Think about your calculus, right? You have a function, and if it converges if it gets close enough, right? Or the integral is equal to this as long as it's close enough in absolute value, right? So abs of this, while the absolute value of the difference between these two numbers is greater than epsilon, keep going. Except be careful. What is abs good for? We talked about this briefly, I think, on Thursday. RTM. It's good for integers. Also labs, labs, etc. Right? There we go. So we'll have integer truncation. In fact, it's in the standard library instead of the standard math library. So what should I use instead? Fabs. Right? So while the difference between those two is great, then I will want to, in fact, I may want previous here or current, I don't know yet. Let's go ahead and update A and B. A should be equal to the arithmetic mean of A and B, but the previous values, right? So A previous plus B previous divided by 2. Is there going to be integer truncation issues here? This is a double, we're good here. Right? And by the way, I forgot to declare them. There we go. Yeah?
Does it matter if one number of the fraction, I guess, is a double?
If at least one of them is a double, then you're good to go. Right?
Oh, really?
Yep.
Like the denominator or something like that.
Yeah, it doesn't matter, numerator or the denominator. So A previous, B previous, but multiplied together. Right? Now, be careful here. Am I ever going to actually change? I change A and B, but what's going to happen in this case? Let's actually go ahead and run this. GCC. Oh, oops. What's wrong? Oh, not next. Oh, it's going to be now previous. Oops. There. Because I got rid of next. What happened? What is happening right now? It's an infinite loop, right? You know what? I never made sure that. Let me move this over. There we go. So, kill it. How do I kill it again? Control C. Okay. What was happening there? I'm updating A and B, right? But I'm only doing it once, and then after that, nothing ever changes. A previous, B previous are the same one. So all I'm doing is saying x is equal to x, x is equal to x, x is equal to x, right? These two are never growing closer because I'm never updating them. I can prove that to you, printf. A and B are equal to %f, and the line A and B. Right? It's just doing that first iteration, 2 and 2.5. Right, that we did over here, 2 and 2.5. So what do we need to do? We need to update the previous values because A and B are our current values. We've got our previous values over here, right? We use those previous values to compute the current values. Now what we need to do is we need to shift, right? These are, we need to store these off into the previous values so that on the next iteration, we can use those values to compute the next values. So, like we did up here, A previous is equal to A, and B previous is equal to B. There we go. I'm going to go ahead and leave that in there so that we can see, this is debugging stuff, right? But this is a poor man's way of debugging. We'll talk about proper debugging later on. Let's go ahead and see if it runs. There we go. And that's much better, right? We got to within 24302, 24303, right? It's not accurate, but it's accurate to what we set, right? 1/10,000th. If you want more accuracy, more significant sig figs, right? Then you need to have a smaller epsilon. Now it'll go way more, not way more, but let's count these up. Int num iterations is equal to 0, and then we'll print that as well. %d num iterations, and then we'll num iterations plus plus. It took us, oh, it only took us 3 iterations there. Okay. If we want super accuracy, still only 3 iterations. It converges very fast, right? I'm sure that if we had different numbers, like, I don't know, it's going to converge very fast no matter what. Not that big, but that big. There it took us 6 iterations, wow. A huge six iterations there, right? But anyway, let's see, oh, and then of course I would need to update these and save these off into the original variables because down here I am changing them, right? So you could have, you know, A current and A previous instead, and then never touch A and B so that you can print them off down here. I'll let you take care of that though, okay? Do not do this. Okay, I'm done debugging. I'm convinced that it works. I'm just going to comment that out. Get rid of it, right, for your final submission. That's dead code. That's debugging code that should not be in the final code. Right? There are much better ways of debugging than this anyway, and we'll talk about those later on. See this thing over here? In fact, okay. I have not played around with this, so I don't know. Let's try it. Okay, there we go. No, I don't want it there. This is what's called a breakpoint. So I've just set this breakpoint, and let's go ahead and, can I run it? No. This is weird. I don't know how it's going to work. I've not played around with the debugger here, but deactivate, no. I want you to start, play. There's no play button. Whatever. All right, anyway, I'll show it to you later. Once I figured this one out, otherwise I'll just do it from the command line. Which GDB? Yep, we have GDB right here. Right? So GCC, AGM, well, fine. There we go. And that produces this file here, a.out, and like a GDB a.out. This is why it's maybe better to use this one over here because the layout is going to be different. Layout next, right? And break at main, run, and there. Now I can just walk through my program. Right? There are no command line arguments provided, so it's going to end up exiting, right? And then dying. Right? But this is just a preview of how we'll take a look at it later. Right there. Quit out of that. Of course, you also have a debugger over here in Eclipse. This little bug over here, right? Debug this program. Okay. I'm satisfied with that. Let's go ahead and do one more exercise. Compute a loan amortization table using the monthly payment formula. So, as an example here, again, I've attempted to whiteboard this. When you borrow money from a bank, of course, they expect you to pay it So if you borrow there's a good old saying, if you borrow $10,000 from the bank, if you owe the bank $10,000, that's your problem. If you owe the bank $1 million, that's their problem, right? If you're too big to fail, then you can go ahead and borrow what you want and get away with it, right? Because if you don't pay, then they're insolvent, or well, right? Can't take money from a stone or whatever. So anyway, but we'll go ahead and consider that we're good actors here and that we did borrow, we borrowed $10,000 for a car or something like that. The rate is the rate period, per pay period. So for example, if I borrow at 5% interest here, that's 0.05, and I'm doing monthly payments, then I divide that by 12. That's the rate up here, okay? The principal is how much you borrowed, so $10,000. And N is the number of pay periods in the loan. So for example, a 5-year loan, there are 12 months in a year, so 5 times 12, that's 60 months. That's where we got this 60 over here. Right? Oh, you know what? This should be 60 up here. That's probably a mistake there. 60. Oh, actually, well, no, that's right, because that is 60. Okay, yeah, that's right. I think. Now I'm questioning that. I don't think that's right. 12, and this should be 12 over here. There we go. And this should be 12 up here as well. Because it's an annual interest, you're paying monthly, so there are 12 months in the year, so it should be, your monthly interest is 0.05 divided by 12. There we go. So this tells you how much interest or how much your payment each month is. So let's go ahead and put this into Wolfram Alpha. So 0.05 divided by 12 times 10 grand divided by 1 minus 1 plus 0.05 divided by 12 raised to the 60. I can do this in Wolfram Alpha, but I cannot use that caret in C or Java. I can, but it gives me something else. And it should be $188.71, okay? $188.71. But there is a fractional value there, right? 0.23 cents. Is a bank going to charge you 0.23 cents per month? No. They will charge it in interest, by the way, but they'll end up doing what? Rounding it. Right? So that's what I've done here. 108, or not 188, transcribed it wrong, $1.71, okay? Now, player's choice here. Do we want to do this in C, or do we want to do this in Java? I did it yesterday in C. Java? Okay. New class loan. There we go. I'm going to steal some stuff. My documentation. Same day, this program generates a loan amortization table. There we go. You get rid of all this demo stuff up here. I'm going to steal the main. Right. And for now, I'm just going to hard code those values to see what we get from that one whiteboarded example over here. We should be able to get $188.71 if we compute it correctly. So I do need the rate, the principal, and the number of pay period, number of terms here. So int months is equal to 60. Double principal is equal to 10,000. Can you do that? $10,000? No. You can't do that. All right, obviously because there was a compiler error, and double rate, and that was 0.05%. Okay.
Why is the month 60?
Because in the example here, we want a 5-year loan, so 60 payments, 60 monthly payments. Again, if you were to do this in a real program, you would parameterize all 3 of these things, read them in as command line arguments, so that you could do a loan for $20,000 at 10% interest over 10 years, right? Or a loan for $200,000 for a mortgage at 4% interest over 30 years, right? So different scenarios. But for this one, we'll just hard code these values so that we can work with it and then generalize it, okay? So I want my monthly payment, double monthly payment, and it's going to be according to this formula over here. Right? So I'll put that above, and let's go ahead and codify that. Well, that's just the rate divided by months, right? In this case, 60, times the principal. And that's the numerator divided by, and we can go to the next line if you want to avoid big giant lines. And in the numerator we have, or denominator, we have 1 minus 1 plus the rate again, which is the same up here. That's the monthly rate. If you want to, you can put that into its own variable. And raised to negative months. Right? But can I do that trick like I did in Wolfram Alpha? No. What do I need to do instead? Math.pow. Or if this were in the math in C, it would be in the math library, just pow. Right? And this is the first argument right here. And that's the second argument right there. Remember, it is negative months, right? Negative n up here. And this one matches with that one matches with that one, and I need one more to match with that one in the numerator, or in the denominator. Right? Good. Sanity check. Right? You don't have to write the entire program at once and then go and test it and debug it. Test as you go along. Do some ad hoc testing. So, system.out.println monthly payment is equal to monthly payment. And again, this is poor man's debugging, right? I'm just going to print this out, see if I get $188. Ah, I do not, right? What's wrong here? I did it right over here. Oh, what's months? Should it be months? Should be 12, sorry. Right? Let's run that again, see if that's right. Still not right. It's a very, very, very small number here, which means that this is probably a very, very large number. Rate, yeah, go ahead.
You're missing some parentheses between like rate divided by 12 and the denominator.
Rate divided by 12 times principal. 1 minus 1 plus math-pow. Oh, there. 1 plus should be over here, right? Because there's a parenthesis right there. So, there. 1 plus the rate divided by 12 raised to the negative. There we go. And then balance them. Does that look right better? Feels better? All right. Now, again, I'll show you this to you later on, but you also, I mean, it's much better if you do more sophisticated debugging. You can set a breakpoint just like I did over the IDE by clicking over here, and that blue dot means that there's a breakpoint. You can hit the debug up here, and it switches perspective to the debugging perspective. And up here you can see all your variables. You can step through your program. You can pause your program. You can resume your program. You can kill your program. You can step into the next one, right? Step, step, step. And my rate, I can look at my variables over here. There's months, there's rate, there's the monthly payment. I didn't have to write this print statement to see what was in that variable. I could just run a debugger and see that it's 188 and 71. I'll go ahead and stop the debugging process here. To get back, make sure that you click back onto your other perspective, out of your debugging perspective, and that would save you a lot of time for having to write a bunch of print statements. Printing stuff as you go along, that's a poor man's way of debugging. We can all afford debuggers nowadays, right? Because they're free. Right? All right, there's my monthly payment, but it's still not satisfying because it was this value over here. Right? This 71233 blah, 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 blah. So I want to round the monthly payment to the nearest cent. Okay. Where do you think a round function can be found? Math dot round. Right? Round the monthly payment and I do want that print statement because I am going to do poor man's bugging here. All right, see if that worked. All right. I'm going to round it and then I'm going to print it out. Is that correct? $189? That rounded it? Rounded it to the nearest whole number, not to the nearest cent though. So maybe in the math library there is a dot round to cents. Dot. Okay, it's not coming up for me. Hopefully it comes up for you, where a bunch of documentation should come up. Round to cents. There is no such thing. Right? Round to hundredths. Right? However you spell it, no, there's no such thing. Right? So, ideas. Yeah.
Multiply monthly payment by 100.
Okay.
Then round it, and then divide it by 100.
Why? What's the suggestion doing? If you only have a tool that rounds to the nearest whole number, then make it a whole number. Move that period over here 2 places by multiplying by 100. Then round, then correct. Move it back 2 places by dividing by 100. And you've adapted an off-the-shelf solution so that you don't have to write your own round to cents functionality, right? Excellent. Good idea. All right. Now I don't need my to-do either. It's okay to put in to-dos as long as once they're done, you remove them. There's my monthly payment. Now what I want to do is I want to pay it down each month by this much, right? So $188.71, right? That's how much you pay each month, but not all of that goes to the principal, right? You've got $10,000 in loan. You pay 5% divided by 12 interest in that first month. So if I've got $10,000 and at 5% interest per month, then that's going to be $41.67 in interest, right, for that first month. The rest of my payment, $188.72 minus this interest payment, that goes to the principal. Right? So what is that going to be? 41.67, so 41.67, and it was 188.71 or 72. Do we remember? Well, in any case, I think it was 72. That much is going to my principal. $147.05. So let's whiteboard that over here. In the first month, you pay rate divided by 12 times principal interest, which is going to be, what did we say it was? 41.67? 41.67 in interest. Then the remaining, which is $188.72, 72, right? Anybody? Okay. Minus $41.67 equals, and that was 147.05. 147.05 in principal, to principal. Right. Then the next month, your principal or balance is updated. You've paid $147.05 off that loan. So instead of $10,000, now you're paying a rate divided by 12 times principal, which is equal to rate divided by 12 times not 10,000, but 10,000 minus that 147.05, right? Whatever that happens to be. $985295. Is that wrong? What?
No, I'm just having trouble following the train of thought, I guess.
Okay. Let's see. So this is why it's called amortization, because you're not paying interest on $10,000 throughout the life of the loan. after the first monthly payment, you don't owe $10,000. You owe $10,000 minus however much you paid in that first month, which is now $9,852.95. So your interest gets updated too, right? Instead of principal being $10,000 here, now your principal is 5295, right? Which is going to be even less interest. It's not going to be $41.67 anymore. It's going to be slightly lower, meaning that the amount that you put towards principal is going to grow. So over the life of the loan, the amount that you're paying towards the interest is going to diminish. The amount that you're paying towards the principal is going to increase until you're paid off the loan. All I wanted to do here was do the first couple of iterations so that I can have some numbers to work with. Right? I know that after that first month, this is the amount of payment that it should be, okay? Or this is the amount that it should be updated. Right? And how much interest in that second month? It's going to be 5% divided by 12 times that new principal, which is going to be $41.05 in interest. You see it went down. Right? It went from $41.67 to $41.05. And consequently, remaining $188.72 minus this $41.05 means that how much goes to your principal? $147.67. 60 was it? 67. Right. That's what we calculated before. That's the monthly payment. Right? Remember that the monthly payment is equal to $188. It was 72 cents, right? Okay. So that's how much we're paying each month. But only part of it goes to interest, and the other part of it goes to principal, right, to pay it down. So I've got my first two iterations here. I'm confident enough that I can actually write this loop now. While loop or for loop? Do we know up front how many iterations we're going to go? Yeah? 60 of them. So, for int month, I'll get away from using I here because what is I standing for? It's standing for the month. It's standing for the first month, then the second month, then the third month, then the fourth month, etc. I'll start it at 1. I is less than or equal to months, or month plus plus. And this should be month. Right? Each time I want to print out the month, print F, the month, the amount that I'm going to pay to interest. Let me put it up here, system.out.println. I'm going to go month, interest, not comma, but month, interest. I'm building a table here. Interest, principal, and then new balance. Those are going to be my 4 columns that I want to print. Right? In the first month, I pay $41.67 in interest. I pay $147.05 to principal. And then my new balance here is going to end up being $98.52.95. And you'll see that that new balance goes down until it gets to 0 in the 60th month. Okay? So let's print all these things out. $.2f. Why $.2f? Percent 0.2f, sorry. I'm calculating what? Money. Money goes only out to 2 decimal places. And the line. And the things that I want to print are the month, the interest, the principal payment, and the balance. Right. Now, I need to define all of these variables. I've already got the month. Principal, let me go ahead and rename this up here, balance. Uh-oh, I'm going to have to rename it here. Right. Let me back up and show you an IDE trick. If you ever want to rename a variable, right-click on it, refactor, rename, and this is my balance. And do you see the magic down there? It magically changed all of the references to it. Yeah.
Is there something like that in C?
Not in the CS50 IDE, but there are things that support that in other IDEs. Yep. All right, this is not balance. This is going to be principal. And then that's balance. There we go. I've already got the month. I've already got the interest. I've already got the principal. Now I need to codify this here and compute it in my loop here. So the interest, double interest, is going to be, just like I put up here, rate divided by 12 times, not 10,000 every month, but whatever my balance is. Right? Double principal is equal to whatever the monthly payment is minus the interest rate, or the interest that you had to pay for that month. And then what else do I need to do? That'll take care of the interest and the principal. I need to update my balance, otherwise I'm never going to get this loan off of my back, right? I need to update the balance to be whatever the balance was before minus the principal that you're paying towards it. Right? Is there a more compact way of writing that? Minus equals. Right. Let's see if this works. It compiles, so let's see if it works. There we go. Well, I did get 60 months. The first month was exactly as I printed or calculated up here. Looks like I screwed up on the monthly interest here. Did I? What is it? I should have left that in there. System.out.println monthly payment is going to be percent or $ plus, actually no, print F, percent, 0.2 F and the line, and then monthly payment. There we go. Now it's formatted as money. Oh, $188, I screwed up somehow. Monthly payment times 100, then divided by 100, right? Double, ooh. Okay, so can you read that documentation or is it too small? What does it return? A long, which is an integer. So I've got an integer divided by an integer, so what happens? Truncation, that 72 cents is lost. One way that I can solve that is 0.0. Force one of them to become a double. And now I've got 71 cents? I thought it was 72 cents. Okay, so I did screw up here then, but that's okay. We're just going to be off by 1 cent here. Instead of 95, it should be 96. Right? 41.05 in interest, and then 147.67, 66 here, because I was off by a penny. Right? But otherwise, you can see that the interest keeps going down, $39, $36, $32 until you don't pay hardly anything in interest. Your principal payment is going up. You start at $147 and then $150, $154, all the way up to until $187. And you see in this fourth column here, the new balance, it goes from $10,000 to after the first month, it's only $9,800. It goes down until you get to, come on, 16 cents. Uh-oh. What happens at the end? Sometimes the bank forgives 16 cents, but so what do we do about? But they're not going to forgive 16 cents in this case. Right? So it's always the case that the bank never forgives money that you owe, no matter how little it is. But they'll certainly forgive the money that they owe you. For example, I told the story yesterday that I had to register my car recently. And because of COVID, I did it over the phone, and they gave me an estimate on how much I paid, so I sent them in a check for that much, and then I got it back, and I realized, oh, well, it was just an estimate. It was off by like $2 or $3, so I call them up and say, well, what about that $2 or $3? They go, well, if it's less than $5, we don't refund it. $5, that is. So they get to keep my money, but I don't get to keep their money. That was the car registration, but same principle with banks here. So what happens? How should we handle this in our code? We're off by 1 here. What we need to do is handle the last iteration separately. And that's usually what has to happen. You have the first one separately to set yourself up properly, just like over here with our arithmetic geometric mean, right? I set ourselves up so that we would have those values, and I did that before the while loop. Over here, I had to handle the last iteration separately because special, you have to overpay a little bit. You have to pay an additional 16 cents in the last month. Right? But there's also another problem here that I'll mention. We rounded our monthly payment. Did we round the interest? Nope, so let's do that now. So math.round of this. And then multiply by 100, right? Then divide by 100.0 because of that truncation issue. So I've rounded the monthly payment. I've rounded the interest. Do I need to round the principal? If these two values are rounded to the nearest 100th, am I going to have to round the principal? Nope. Consequently, I won't have to round the balance or the principal because the principal is already going to be rounded. And that's a little bit better now, right? Except that, remember, I've already stopped that last iteration and put in a to-do reminder to myself here to take care of this. I'll let you do that as an exercise, though, okay? You'll do something very, very similar anyway on your second homework where you're doing not a loan, but a 401k savings plan. And you'll see that instead of going down to 0, you'll grow until you get a certain amount of money or something like that, okay? Any questions? Let me check online. Nope. Nope. Why is it rate divided by month? Because it's a monthly interest. It compounds monthly instead of annually. Some schemes would have values compounding daily, in which case you would divide by 365. So, yep, that's how finances work. Right? No questions? Okay. Then I will go ahead and transition and have a good Wednesday tomorrow.